The pressure switch, or water level switch, is crucial for preventing overfilling in your Maytag washer. In top-load models, like the MVW X series, it's generally found on the right side of the cabinet, behind the control panel, or under the top lid. Front-load models, like the MHW series, typically house it behind the front panel, near the door hinge, often requiring removal of the toe panel. Always unplug the washer before you start. Visually, the pressure switch is a small, usually round or square plastic component. An air hose connects it to the washer's tub. This hose allows the switch to detect water levels based on air pressure. You'll likely see electrical terminals for wiring. Some newer models might have an adjustment screw, but these rarely need calibration. The switch is usually rated for 120 volts AC and water exposure PX4 or higher. For top-load Maytag washers, start by unplugging the machine to ensure safety before any work. Next, locate and remove the screws that secure the control panel or top lid. Use a screwdriver to carefully unscrew them. Gently tilt the panel or lift the lid to access the internal components. Be careful not to force anything. Look for the pressure switch, which is typically mounted to the cabinet wall or a nearby support structure. Before disconnecting anything for replacement, take note of the wire connections to ensure proper reconnection. For front-load Maytag washers, begin by unplugging the appliance. You'll typically need to remove the toe panel at the bottom front of the washer. In many models, the pressure switch is located behind the front panel, accessible after removing a few screws. Look for it near the door hinge. Again, take note of the wiring configuration before any disconnections. Several symptoms indicate a failing pressure switch in your Maytag washer. Overfilling occurs when water continues to fill beyond the selected level, risking flooding due to the switch failing to detect proper water pressure. Underfilling means the washer doesn't reach the proper water level, leaving clothes inadequately soaked, as the switch doesn't signal enough pressure change. The washer not filling at all halts the cycle completely, often because the pressure switch doesn't activate to allow water inflow. Cycles not advancing leaves the washer stuck in one phase, such as fill or wash, since the switch fails to confirm water levels for progression. Error codes like F8E1LF or LOFL appear, specifically related to water level detection failures from the faulty pressure switch. If you experience any of these, the pressure switch is a prime suspect. Smart washers might even report switch status via a connected app. A multimeter is your primary tool for testing. Disconnect the wires from the switch. Set the multimeter to measure continuity, ohms. Blow gently into the air hose connection on the switch. The multimeter should show a change in continuity as the diaphragm activates. No change typically indicates a faulty switch. For safety, always disconnect power before testing. In this case study, imagine a Maytag MVWX655 DDU top-load washer that keeps overfilling during cycles. The first step in diagnosing this issue is confirm that the drain isn't clogged, as that's a common cause of overfilling. If the drain is clear, the pressure switch is likely the culprit. This switch monitors water levels and signals the control board to stop filling. The air hose connected to the pressure switch might be clogged with soap buildup, preventing accurate pressure readings and causing the washer to overfill. To resolve this, disconnect the air hose from the pressure switch and clear any blockage by blowing through it or using compressed air. If the switch itself is defective, replace it with an OEM part. Regular cleaning of the air hose can prevent this issue from recurring. Newer Maytag washers with smart capabilities can provide diagnostic alerts for pressure switch issues through mobile apps, saving repair time. Future trends include wider adoption of ultrasonic sensors for more reliable water level detection, potentially phasing out traditional pressure switches. Capacitive sensors may also replace traditional pressure switches. Eco-friendly designs also emphasize precise water level control for conservation.